Hello and welcome to the 3DuxDesign educator tutorial on the Sustainable Farm and Turkey Refuge project. A brief introduction, it is Marcy Klein speaking today, sharing with you this tutorial, and I'm one of the co-founders of 3DuxDesign. Getting started with the materials that you are going to want for this project. The project is scaffolded, so you may or may not need everything on this list, but at the very least, you will need the Go Box classroom kit with all of the cardboard and connectors needed for 25 students to do this project in groups of 2 or 3. You will want the machine maker add-on kit, or you would need the materials that are in the kit, including pom-poms, straws, string, metal brads that are paper fasteners, pipe cleaners, and I believe that's it. But as we go through the project, activity by activity, you will see what materials are needed for each one. If you are going to incorporate the LED lighting and the Build-A-Bot parts of this project, you will want the Build-A-Bot add-on kit. And the flexible sitemap is completely optional. It makes it fun as a nice place for the farm to be situated, but is by no means necessary for this project. In addition to the 3Dux materials, you will want scissors, tape, some paint or crayons or markers to decorate the students' projects, and some draft paper. As students are going through the design process, they should have an opportunity to draft out. In addition to the engineering design process, we're going to focus a bit on agriculture and farming, so your students will have a little bit more understanding of what that's all about. And there will be plenty of opportunity for researching these fields and discussion about how to make farming and agriculture sustainable for years to come. There is also an opportunity for literacy and digital literacy through researching their projects, life science, sustainable development goals, and how they apply to agriculture and farming methods in modern times. And as students will be inventing solutions to make farming more sustainable and productive, they are going to have a great opportunity to really start thinking like an inventor and with the innovation mindset. And of course, there is a ton of opportunity for good old-fashioned hands-on fun with this project. Your students are going to have a blast, and they probably won't even realize that they're learning. So the Sustainable Farm and Turkey Refuge project is actually 6 individual projects. The level of complexity is scaffolded from project number 1 through project number 6. And depending on which projects you do, your students from K through 8 can enjoy this project. The challenges can be anywhere from 30 to 60 minutes apiece, depending on the depth of complexity and research, how deep you want to go into the concepts around the project versus just running through the project itself. How you want to use this project is really up to you. You can divide it so that different grades are doing different challenges within the booklet, or you can have one class go through one part or activity at a time so that they're completing all 6 of the activities. And that is really dependent in part on the grades that you're teaching, how much time you have with each group, and what and what your educational and learning goals are for the class. Of note, if you're doing different projects with different grades, do not feel like you need to take everything apart in between classes. There is plenty of opportunity for your younger students, even if they can't do some of the more complex activities themselves, to play with the ones that older students have done. So for example, if your kindergarteners are not quite able to make a linkage and a pulley system for the pumpkin packing facility, they can certainly play with it after the fifth graders construct it. So it's a great opportunity for cross-grade learning and engagement. Incidentally, this is a great project also in its entirety for a STEM night with different grades doing different projects. Ways to extend the learning for this project. I will share with you some literacy and digital literacy opportunities through the course of the projects. I have some recommendations for specific read alouds that you can incorporate into the activity. And I also share with you a number of video links, which are great introductions to each different activity, and also open it up for class discussions. Some of the videos are really involved in sustainable concepts and are a great opportunity for class debates and sharing opinions. You can also level up this project with some 3D printing and robotics incorporated into the activities. And there is also a great chance for community-based connections. So you can potentially schedule live or virtual trips to local farms if that is an option for your classroom. Each one of the activities in the Sustainable Farm and Turkey Refuge project goes through the design thinking process, where students begin in the imagine phase, where they're really digging in and understanding the problem quite deeply. Then they move on to the design phase, where they're drafting out ideas, comparing ideas. It can be a little bit heated discussion between team members as to what design they want to move forward with. But it's a great opportunity for students to really brainstorm, think outside the box, and be super creative with their ideas. Once they go through the design phase, your student teams will come up with a few of those designs that will move on to the build or the prototyping phase, where the students will take their written ideas and designs and build them in three-dimensional models and test out their designs. Once they come up with their final prototype, they move into the share phase, where they're creating presentations. And here, again, is an opportunity to incorporate lots of other technology as students are creating their presentations. And we'll go through that a little bit more. But in general, they can do written presentations, they can do photography-based presentations, video presentations, and of course there's great chance for students to work on some of their digital technology skills through creating video presentations, or they can do live presentations for the entire classroom. But there's lots of room for creativity there. The share phase is also a great chance for students to get constructive criticism as they present their project, to get feedback from their peers or the community that's in the audience listening to their presentation. That is a great opportunity also for students to hone their communication skills. So if you are watching this video on our website, you are most likely already in the right place. But in case you're not, and you're watching this video from somewhere else, I will share with you how you actually get to the project page. So you start by going to the 3DuxDesign website, and you click on the orange button that says Learning Resources. That will take you to all of our design challenges, where you'll find a wide range of different types of challenges. But this particular project sits within the blue button titled Basic Design Challenges. From there, you will find holiday, seasonal, and more fun projects. And then if you scroll down, you will find the farm and agriculture education projects. So when you click on that, you will come to the project page. And on the project page, you will find a number of resources. So you will find student booklets. You will want to print one student booklet per team. You will also find student templates. And again, one template for each team. And then you will also find the facilitator guide, and most likely you will find this video living on this page as well. So getting started, before you jump into all of the projects, your students will need to create the farm scene. So for this, they're going to need the templates, they will need scissors and tape, and they will use cardboard from the 3DuxDesign kit along with the connectors. They're going to want to assemble their fence, the animals, a paper barn, and they can make the signs if they want. They're there, they're not required for the project, but they definitely make the decorations nice. Now, in terms of cutting out your paper shapes, you can see in the image in the middle, you can use the 3DuxDesign connectors. The image on the right shows you how you use the 3DuxDesign connectors with paper, because obviously paper is thinner than cardboard and the connectors are designed for cardboard. So in this case, what you want to do is use little pieces of cardboard. We call them backers. So on the picture on the left, you can see I took a cardboard triangle and I placed that right behind the turkey piece of paper and attach the connectors to the bottom, and that will allow all of the characters to stand up quite sturdily. If you prefer to have your students do the only paper version, the way that works is on each template for the animals, there's some lines at the bottom, and if the students cut along the lines, fold 2 pieces of the paper backward and 1 piece of the paper forward, they will create a paper stand for each one of their characters, just like the image on the right. So we will now begin with challenge number 1, the feeding frenzy and catapult activity. In this project, the project includes asking students to design a feeding system for the petting zoo that is safe for both the animals and the visitors to the farm. So it's a great opportunity to talk about the potential germs involved that can be transmitted between animals and humans, both directions. We do also have an optional video on the ethics of keeping animals in zoos and caged. So that's an opportunity for you to have a class discussion and debate if you like. We also include a 3-minute video that is student friendly on the vocabulary and the actual machine involved in creating a catapult. And once that is done, your students can break up into their groups and draft out their ideas for how they are going to catapult food, which in our kits is actually represented by a pom-pom, into the cage that they made out of paper with the animals inside. The students will find that it is actually a little more challenging than it looks. The height of the fulcrum, where the fulcrum is along the length of the cardboard, stick, is going to affect the direction of the pom-pom, and then whether or not one side is weighted will also affect the direction that the pom-pom goes. So your students will have plenty of opportunity to try and try and try multiple times till they figure out exactly how the best design works. And of course, there's like 100,000 different designs that will work. So each one of your student teams might come up with a completely different design. But in the end, it's a great opportunity for each one of your student groups to spend a minute or 2 describing how they got their feeding device to work, and maybe some of the challenges that they had along the way. So this is a great project for your earlier learners. It's a relatively simple machine to make, and students in even kindergarten, 1st grade can easily get this project done in 1 class period. In challenge number 2 is a slippery slope. and it involves inclines and friction. And in this activity, we ask students to design a ramp that allows the pumpkins to slide out of the pumpkin packing facility and into the pumpkin cart quickly and efficiently, but not so much so that they're losing pumpkins off the side of the ramp. So there is a chance for students to create different heights and different slopes of ramps and test out the speed at each level. The students can also change the different materials along the surface of the ramp as well. So cardboard might be a nice material for sliding pumpkins, but if they want them to move a little bit faster, perhaps they can use something like clear tape or vinyl surfaces. And if they want their pumpkins to move slower, they might pick something more rough. And of course, depending on the slope, the pumpkins will be either faster or slower, and in some cases may not move at all. So the students can, again, prototype different designs, test different slopes. And if you do have opportunity for a timer or videoing this project as it's moving forward, the students can actually transfer their videos into a video editing app like iMovie and slow it down and actually do some scientific timing of the pumpkins with different slopes and different surface textures. So it's a great opportunity for students to use, the scientific design and scientific method and collect data and come up with conclusions. And again, of course, presentations. In this project as well, we do have a video on our website with different slopes that your students can look at and learn all the technology, all the vocabulary around inclines and friction. And here's an example of how the project might play out. So here you see two different slopes and the pumpkin moving faster with the steeper slope. And here, same slope, different materials. We put shiny vinyl on one side and you can see the difference as well. So this project would be good, again, for kindergarten, really up through any age group. There is also an opportunity during this project to skill up a little bit. If you have 3D printers and you're teaching CAD, have your students design, rather than using cardboard as the different ramps, have them design different ramps and 3D print them and play around with, the thickness of the ramps and the surface material, well, not surface material, but the surface design and how they can make it, more smooth for more efficient pumpkin sliding. Do they need ramps, or ledges along the side for their pumpkins to not fall off the side? So lots of different designs. And again, this project can be done literally with all ages. Right now we have an 8th grade class coming up with some CAD that will also be showcased on this project page if the students are successful. We will see in a couple weeks. Project number 3 continues the pumpkin packing facility and efficiency with pulleys and linkages. So in this case, we ask students to be able to lift the pumpkins out of the patch with a pulley device and then use a linkage to rotate their pumpkin and then drop it off into the cart. So I will share with you what this project looks like in a moment. But first, like all of our engineering projects, we do have a video tutorial that allows you to share with your students different terminology, vocabulary that goes around these type of engineering projects and forces. Your students will draft out their ideas of how they're going to design their project and then go through the design process, testing out their project. And here is what our example looks like in this case. So here is the pulley device that we created. And here it is in action. We're lifting the pumpkins. We are sliding them around with a pivot and dropping off our pumpkins in the pumpkin cart. This is also a great project for potentially older students to construct. So this would be a good project for 4th grade and up. But your younger students, once your older students create the project, this is a great fine motor activity for the little ones and a ton of fun, of course. So challenge number 4, helping a farmer in need, is a great capstone project that allows the students to apply all of the learning that they gained from the first few challenges and put them together to combine any 2 simple machines into a Rube Goldberg style project. The story behind this project is that our farmer accidentally slipped in the pig pen and hurt his leg and is now no longer able to get around his farm efficiently. So your students have an opportunity to design an assistive device that will help the farmer get around the farm easily. They can use pulleys, linkages, levers. They can do a wheel and axle if they're going to make a little cart. Hopefully not the catapults, but you never know. They might want to catapult him from one place to another. That's where all the creativity comes in and the fun. But it allows the students to apply all of the learning from the first few projects and apply it into something that has no real preset design or rule. So it's a lot more open-ended and requires a lot more creative problem solving than the first few projects. So that's why we consider it a capstone. And this would be a great project for 3rd, 4th grade and up. And again, this is a great project for sharing and presenting to peers because these projects will look completely different. So it's a really fun way to hone communication skills and have students sharing. So challenge number 5 is a chance to level up with circuits. And in this project, we're going to create a smart lighting solution for the farm. So it starts with an optional video that you can share with your students on the effects of light pollution and its impact on the environment, followed by the project. So in this project, the students will learn how to create a simple circuit for a light, and then they will create an interrupted circuit that requires a human or some type of character to set off the circuit or complete the circuit to set the light on. So I have on the right basically the order in which your students can build their circuit. So I start with an image. The top left just shows you how the circuit works. Both the battery and an LED light are directional. So there's an anode and a cathode. The cathode is the positive. On the battery, you will see a plus sign on the top of the battery. And on the LED light, the positive is the longer prong. So your students can start by designing, by just drafting out the circuit itself, making the battery, the light, and the positive and the negative parts of the simple closed circuit. After that, the best way for your students to do the actual circuit is to first start by laying down the negative side. So they're going to start where the battery would be and create basically essentially a U out of the copper tape, ending with the short end of the light bulb. After that, they can place the battery down with the negative side, which is kind of bumpy looking, down on the top of the copper. So it is attached, not attached, but just on top of the copper. And from there, your students are going to be able to complete the circuit by taking another piece of copper tape and attaching it from the top or the positive side of the battery around, making a right angle if necessary, and attaching it to the long or the positive arm prong of the LED light. And if your students do that correctly, the light will automatically go on. And they just created a perfect, simple closed circuit. Now that is not smart lighting, that's just gonna stay lit forever until the battery dies. So now to create a smart lighting solution, we're gonna have your students, and this is the 1, 2, 3, 4, 5th picture, the one right smack in the middle. What we do is you just take a fingernail and literally rip the copper conductive tape somewhere along the line. It doesn't really matter where it is, as long as it's not in the way of either the battery or the prongs. That will rip the circuit, and now we have an open circuit. Your students can use, make a character whose feet are essentially conductive by adding conductive tape to the bottom of one of the three-way connectors. And when you see on the last image at the bottom, the connector with the conductive tape is placed over the open part of the circuit, the light will go on again. And I can show you an example of how that would work in real time over here. So here's your open circuit, and we have copper on the bottom of the butt of our little animal here. And as he closes the circuit, the light will go on. And this is designed to represent smart lighting solutions as your students rig this up in the farm, at the entrance to the farmhouse. They will see that the farmer or whoever has electrified feet will set off the light to go on, but when nobody is in the proximity of the front door, the light stays off. So it's a much more sustainable and efficient way of lighting. Next project, number 6, is the Wobbly Turkey Bot Refuge. So here we have an optional video again with the pros and cons of buying local. And also we have another video on the sustainability of meat. And it's a great opportunity for students to learn about the meat and cow industry and the pros and cons, and how cows can actually negatively impact our environment and some potential solutions. So after going over those videos, you can lay out the project. Here, you're going to have your students create a little turkey refuge out of the fencing, the paper fences. And then they're going to create a turkey bot by creating a simple circuit using an oscillating miniature motor. The challenge here isn't so much creating the actual circuit, but it's actually getting the darn turkey to travel in a straight line, which is more challenging than one would think. And here again, like all of our challenges, allows time for presentations at the end of the project. And here is our little turkey bot who just seems to love to travel around in circles. So how your students will construct a bot, in the Build-A-Bot kit, you will see actually the battery that you see in this picture is not the batteries that we use. Ours are a slightly larger and flatter battery, but same idea. So you will have a bunch of different materials, but you will specifically have some of these double-sided adhesive spongy pieces of tape. You will have an eccentric miniature oscillating motor, where your students can see that the little spinning part of the motor is not perfectly round, but it's only essentially a half circle. And as that rotates, it creates that eccentric circumferential movement that creates the wobble itself. And you can compare that to, like, if any of your students have ever seen a washing machine where all the clothes get stuck on kind of one side and the washing machine is turning, and as you can watch it, it's wobbling. So that's sort of the same mechanism that is happening with these wobbly turkey bots, or in this case, triangle bot. So in any event, the way the students can construct their bots, of course, they can use any kinds of cardboard and connectors as the stands, but the electrical component involves attaching the motor with one of the pieces of two-sided adhesive tape. And then they're going to stick one more piece of tape on the cardboard itself. They're going to adhere either side of either one of the wires, either the red or the blue, so that the wire is exposed. And then they're going to attach from there, they're going to stick the battery on top of that. The next step is to take another piece of adhesive tape and stick the other wire onto that piece of tape, and then place it face down on top of the battery. And that will essentially make it start wobbling already. The direction of, where the battery is and the direction of the motor will definitely affect the direction that your bot goes. We do have a whole web page on this project with its own tutorial if you want to focus on getting the bots to go the direction that you want. It has to do with changing the center of gravity and changing the design of the bot and changing the amount of friction on each side of the bot to try to get the bots to go straight. I can share.
In the 3DuxDesign Builder Bot Kit and project, students will use the engineering design process as they try to design a motorized bot to go straight. In the process, they'll use a bunch of different physics concepts like Newton's first and second laws, as well as the concepts of mass, physics, and forces to design their bot appropriately. While the project is designed for students to learn by doing, you can use this video for some tips on how to help support your students. One factor that will affect motion is the orientation of the motor attached. Here you can see the motor is facing down, and this particular project, the bot is going pretty much in circles. Then we put it at a 45-degree angle. And here you can see he is going straight, although not officially straight, he still straightens out a bit. Here we put the motor horizontal, and he again is sort of going straight, but not really sure where to go. Your students can also work a little bit with different mass on different sides and a different center of gravity. So here it appears that the more mass on one side pretty much increases the friction on that side, and the bot will spin the opposite direction. And you can see this in a number of different examples with different amounts of weight on either side. You can also play around with different orientations, and using the horizontal format, students can actually play around with the connectors quite a bit, and that will significantly affect the direction that the bot goes. You can explain it sort of like a rudder on a boat. These students decided to exploit their bot's tendency to go to the right by designing their track to accommodate his needs. They also made him tiny, so he moves much faster. This group of students actually used the pipe cleaners in the kit to create arms to prevent their bot from his tendency to keep turning to the right.
So those are the 6 different projects that are a part of this activity. You will also find available a number of cardboard hats. So different ways to cut, connect, and attach your cardboard using a whole wide range of typical craft materials that you most likely already have in your classroom. So these are also on our website, and you're free to check these out as well. And we are also excited to be working with the organization Starmatica to create leveled text opportunities to increase the literacy component of these projects. So Starmatica has created some resources based on this project for reading and for just deeper learning and tying to the language arts standards as well. They have a number of different book recommendations and leveled texts on their website, and also some teachers pay teachers resources, which you should be able to find below on this webpage, links as well. If you have questions about any of these activities or would like professional development for your educator team, we are more than happy to discuss that with you directly. You can reach out to us through our website, info@3duxdesign.com, with your inquiry, and we would be happy to help support your classroom, teachers, and students in any way we can. We at 3Dux love to share student projects. So once your students are done doing the farm challenge, please feel free to send us their projects, their videos, their photos, their presentations, whatever you want to share with us. We love to share it with our 3Dux design community. So thank you, and enjoy your projects.